Going to take a look at the climate in the Foundry by looking at those specific subregions we've mentioned beforehand, and in general the pattern we see here compared to the rest of North America, we get a little bit more precipitation, so no matter where we're at, we're considered a humid climate, but we're also temperate. And so in the Foundry it's humid and it's temperate. Temperate meaning there's seasonality. There's winter, spring, summer, and fall. It's not all just one, it's all not winter, not just summer, like it is in other parts of the world. So just to begin with, we'll go ahead and start off looking at the megalopolis. And we're going to zoom into this particular area. And we can see, as far as, let's look at those latitudinal and altitudinal and also maritime versus continental effects. And so we see if we include Boston in the megalopolis, which is we should, it's the top, it's essentially the most northern location. We can see here all along the megalopolis region, it's part of this green color. What does that green mean? It's a humid subtropical climate. Humid subtropical is what we see in much of the south, much of Dixie. And so here we see warmer temperatures on average. And so what's going on here? Why does a more northern location have a similar climate as these Carolinas, more southern areas? Once again, the role of maritime influences. And so because it's along the coastline, its highs don't get as high, but its lows don't get as low. And so it doesn't have those brutally cold winters. Now, it can definitely get cold in Boston in the wintertime. I'm not saying it doesn't, but it's nothing like it does as far as temperatures in Chicago, Des Moines, Omaha, Minneapolis, Detroit, places like that. When we also look at the megalopolis, it does have this particular green color, but as you go farther away, you do see temperature goes down, and that's in all directions. Essentially, you could say farther away from the coastline because we have the Appalachian Mountains coming right through here. So now we can see the role of altitude and why we have temperature variation. And so the role of altitude in terms of the Appalachian Mountains go up in temperature, we go up in elevation, we go down in temperature, and so the Appalachians we can see there. Also, we're going to more northerly latitude, which also is going to affect climate and temperature. And so we look at the megalopolis. It is heavily urban, and so if it wouldn't be so urban, it would be conducive to some agriculture. But it's so urban, that doesn't really matter, but it does in the case of the Rust Belt. And so the Rust Belt, for the most part, in this particular area, we see blues. And so what do the blues equal? They equal DFB and DFA, a warm, summer, humid, very important word, continental. So that means we're going to get a little bit more variation in the temperature throughout the year. So the summers are going to get really, really warm, but the winters are going to get very, very, very cold. And if you know anything about Indiana, or especially northern Indiana, or Illinois, Chicago, parts of Ohio, boy, you can get some brutally cold winters. But you can also get some really, really hot summers. And that's very characteristic of the continental effect. So some other patterns we see in the Rust Belt is along the southern edge. We see the humid subtropical climate. So is that the border between, would say, the Rust Belt or the Great Lakes and the South? Some would say it is. Others would say it's not. But definitely in the case of Indiana, it does do a good job of separating what I would argue is more northern Indiana versus southern Indiana. And that's also cultural differences there as well. Other things to keep in mind here is we see the orographic effect. So we see on this particular side, it has this green air color, this lime green that says oceanic. And whoa, oceanic? Well, this isn't anywhere near an ocean. So what's going on there is orographics at work. And so we have a warm, moist air mass that's kind of in this general direction, bringing air up. Then the westerlies take over, and essentially we get orographic precipitation, which creates what appears to be kind of like an ocean, which it's always creating that mist. So thus the Smoky Mountains. The reason why the Smoky Mountains are smoky isn't because they're have a smoking problem or because of fire. It's actually because it's constant mist from this warm, moist air being lifted by the Appalachian Mountains and then lifted, condensation effect, as that warm, moist air cools, condenses, and comes back down as rain. So that's the quick 4111 here. And so once again, ag is something that's very common in those D climates that we see in this particular area. Now let's go to Canada. So Canada, we see in terms of latitudinal, the only place that sticks down this far is the Canadian core or the Canadian corridor. And so here you're going to get a little bit of that latitudinal effect in terms of warmer temperatures. And so this particular core area, it's the economic core, it's the population core, demographic core, it is also the agricultural core of, and the reason why this area became so important, this area that used to be called Upper Canada, which is today Southern Ontario, is because of its just agriculturally in the perfect situation in the case of Canada. I mean, it would be greater to probably be better to be somewhere else, a little bit more southern, but in the case of Canada, it's about as good as it gets agriculturally. And so what you got going on here is lowland area. This is not part of the Canadian Shield. It's part of the central lowlands, which also comprises the rest of the Rust Belt. And so the central lowlands created by the glaciers, so essentially flat areas, but also lowlands. Lower elevation means higher temperature. Also, what you got going on here is the maritime versus continental effect, and so you have the role of the Great Lakes in helping to moderate temperatures. And so in the wintertime, it actually doesn't get that bad, but it does in the summertime get a little bit warmer than the other areas of Canada because of, once again, those latitudinal effects.